So number one is going to be write the electron dot formula for calcium sulfide, okay? So this is an ionic bond between two nonmetals. Calcium has two valence electrons, and it's going to lose those two valence electrons in order to form a octet valence shell underneath. Sulfur has 6 valence electrons. Sulfur is going to gain those 2 electrons. So you're going to put a 2 minus, okay? And then we complete it by giving sulfur a full 8 electrons around its valence shell. Number 2, write the electron dot formula for hydrogen bromide, okay? Covalent bond between two nonmetals. We're going to count the total number of valence electrons. Hydrogen has 1, bromine has 7, so we have 8 total valence electrons. Now we're going to go ahead and put them together. So we have hydrogen and bromine. Go ahead and bond them. That bond is worth 2 valence electrons, so we're down to 6. So now the next step is to add electrons around the central atom. Okay, let's look at hydrogen. Remember that hydrogen only wants 2 valence electrons because it only has 1 energy level. So this covalent bond around it satisfies it, so we don't need to put any electrons around hydrogen, okay? So let's go ahead and use these 6 valence electrons here. We're going to place them around a bromine. So there's 1, 2, 3, 4, 5, and 6. Now bromine, if we do a circle around it, it's happy. Hydrogen is happy. This is the electron dot formula for hydrogen bromide. Sodium chloride, NaCl, an ionic bond between a metal and a nonmetal. Sodium has 1 valence electron. It's going to lose that. Calcium is going to take that electron and gain an electron, so it's a negative ion. We complete it by putting 8 electrons around the valence shell. This is the electron dot formula for NaCl, sodium chloride. Next we have SF2. Okay, this is a covalent bond. So the first thing we want to do is we want to count the total number of valence electrons. Sulfur has 6. Fluorine has 7 valence electrons, but there's 2 of them. So we have 14. So there's a total number of 20 valence electrons. Now we're going to do our shell. We're going to do F, S, F. Go ahead and bond them. That bonding takes 4 electrons, so now we have 16. Okay, so now we're going to place electrons around the outer atoms. Let's start with this fluorine on the left. Now it has a full valence shell. Now I have 10 left. We're going to start with the right-hand fluorine. Now that has a full octet. That took 6 electrons. We have 4 left. Now we're going to place the 4 remaining ones to the center atom. Let's do a check. Left fluorine's happy with 8. Sulfur's happy with 8. Fluorine on the right's happy. This is the electron dot formula for sulfur difluoride, okay? Take a look at that. All right, so next, electron dot formula for potassium bromide, an ionic compound, okay? Potassium has 1 valence electron. It's going to lose that, so it's a positive ion by a factor of 1. Bromine is going to gain that electron, 1 electron, so we symbolize it. It's now a negative ion. And as a result of stealing that electron, bromine now has a full valence shell of 8 electrons. This is the correct answer, guys. Moving on to NH3, covalent bond. Total number of electrons. Nitrogen has 5 valence electrons. Helium has 1 valence electron, but there's 3 of them. So we have a total of 3. So we have 5 plus 3, 8 total valence electrons. We're going to put the lone atom in the center, which is nitrogen. So the structure is going to look something like this, guys. You're going to have an H, you're going to have an N, H, and then you're going to have another hydrogen, okay? Go ahead and bond them, all right? So that bond took 6 electrons, so we're left with 2. So now we're going to put these 2 remaining electrons and we're going to give it to the central atom, which is nitrogen. Do a check. This hydrogen is happy because it has 2 valence electrons. Let's look at this hydrogen. This hydrogen is happy because it has 2 valence electrons. This hydrogen is also happy for the same reason. Let's look at nitrogen. Nitrogen's happy because all around it now has 8 valence electrons. So this is the correct answer for NH3. Moving on to magnesium oxide, ionic bond. Magnesium has 2 valence electrons, so it's going to lose those and become a positively charged ion. And you're going to put a +2 because that's how many electrons it lost. Oxygen is going to gain those 2 electrons, okay? Now we're going to complete this by signifying that by stealing those 2 electrons, oxygen now has a full valence shell. This is the correct answer. Okay, let's move on to CH4, otherwise known as methane. It's a covalent bond. Total number of valence electrons. Carbon has 4. Hydrogen has 1 valence electrons, but there's 4 of them. So we have a total of 8 valence electrons. You always want to put the lone atom or carbon in the center. In this case, we have a carbon, so carbon goes in the center. So here's how it's going to look, guys. Carbon's in the center, and we're going to have the 4 hydrogens surrounding it on every side. Go ahead and bond them. Okay, so those bonds took up the 8 valence electrons that we have, so we have 0 left, okay? If you do a check, everybody's happy. All the hydrogens around are happy because they have 2 valence electrons. Carbon in the center is happy because those covalent bonds, each one has 2, so there's 8. So this is the correct electron dot formula for methane, CH4, okay? Moving on, electron dot formula for sulfur dioxide. Total number of valence electrons. Sulfur has 6. Oxygen has 6 as well, but there's 2 of them for a total of 12. So we have a total of 18 valence electrons, okay? Put the lone atom in the center. That's going to be sulfur. Bond them. There's 2 electrons and 4 electrons, so we're left with 14, okay? So go ahead and place electrons around the outside atoms until they have an octet. I'm going to start with the left-hand oxygen. This now has an octet, but there's 8 remaining valence electrons because I use 6. Oxygen on the right, I give it 6 valence electrons to give it an octet. I'm left with 2. I'm going to place these 2 remaining electrons with the center atom. Let's go ahead and do a check. This oxygen right here on the left is happy because it has 8. Sulfur is not happy because it only has 6. The right-hand oxygen is happy because it has 8. So we have a problem. We have to fix the center sulfur. So what are we going to do? We're going to take, you can use either one, and I'm going to take 2 electrons from the right-hand oxygen, and then I'm going to place a double bond between the sulfur and the right oxygen atom, okay? Now let's do a check. Left-hand oxygen's happy, sulfur's now happy, right oxygen's happy. This is the correct dot formula for sulfur dioxide. Moving on to carbon monoxide. Carbon has 5 valence electrons, okay? Carbon has 4 valence electrons. I made a mistake. Carbon has 4 valence electrons. Oxygen has 6. We have a total of 10 valence electrons, guys. We're going to put them together, go ahead and bond them. That's 2 valence electrons, so we have 8. So we're going to go ahead and let's try to give each one a full octet, okay? Let's start with oxygen. I'm going to give it 6 electrons to give it an octet, so I have 2 left. The remaining one I'm going to give to carbon. Let's do a happiness check. Carbon is not happy because it has only 4 electrons. Oxygen is happy. So what are we going to do? Carbon needs 4 more electrons. So what we're going to do is I'm going to take 2 electrons from oxygen and I'm going to take 4 total, 2 from the right and 2 from the bottom, and I'm going to create a triple bond. So now let's do our happiness check, okay? Carbon 2, 4, 6, 8 is happy, and oxygen is happy as well. This is the answer. Okay, we're moving on to write the dot formula for carbon tetrachloride, okay, CCl4. So carbon has 4 valence electrons, chlorine has 7, but we have 4 of them, so we have 28 of those for a total of 32 valence electrons, okay? So Carbon always goes in the center, okay? So we're gonna put carbon in the center, and we're gonna have the chlorines surrounded, okay? So this is gonna be the structure for chlorine, okay? Go ahead and bond them. So with those 4 bonds, I used up 8 electrons, so we have 24 left, okay? Now with these 24 remaining electrons, I'm going to place them around the outside chlorine atom. So let's start with the top chlorine. I'm gonna place 6 around them. Now I'm left with 18. On the right-hand chlorine, I'm gonna give it 6. I now have 12. Chlorine on the bottom, I'm gonna give it 6. I have 6 left. I'm gonna place 6 around the last chlorine. I'm out of valence electrons, but if I do a check, everybody's happy. Chlorine has 8 valence electrons as a result of those 4 covalent bonds, and every chlorine has 8 valence electrons around it. So everybody's happy. So that's the formula for carbon tetrachloride, okay? Next, we're gonna do the electron dot formula for HCN, otherwise known as hydrogen cyanide. So what are the total number of valence electrons? We have hydrogen has 1 valence electron, carbon has 4, and nitrogen has 5 for a total of 10 valence electrons, okay? Carbon always goes in the center, so we're gonna go ahead and label it as such, HCN. We can just leave it like we saw it, okay? Go ahead and bond them. Those 2 bonds take up 4 valence electrons, so we're left with 6, okay? So we have 6 remaining valence electrons, right, guys? Let's look at hydrogen. Hydrogen is already happy because it has the 2 valence electrons from the covalent bond. So we're gonna distribute these 6 valence electrons around the center atom, okay? So I'm gonna put 6 valence electrons around nitrogen, and now nitrogen has a full octet, but I'm out of valence electrons to give. So let's do a happiness check. Hydrogen's happy, carbon is not happy because it needs 4 more because it only has 4 right now. Nitrogen is happy. So what are we gonna do? We're gonna take 4 electrons from nitrogen. So I'm gonna take it from the right-hand side and the bottom, and we're gonna use those 4 electrons and we're gonna create a triple bond. So now if we do another happiness check, we're gonna see that everybody's happy. Hydrogen's happy, carbon's happy, and nitrogen's happy. This is the correct answer, okay? Moving on, we have O2, okay? Oxygen has 6 valence electrons, there's 12 of them, so we have a total of 12 valence electrons. Go ahead and put them together. So we have OO, bond them, that takes 2 valence electrons, so we have 10. Let's go ahead and give the right hand 6 valence electrons to form an octet. We have 4 left, so we're gonna put the remaining ones on that oxygen, okay? Let's do a happiness check. Left-hand oxygen is not happy because it only has 6. The right-hand oxygen is happy because it has 8. So what are we gonna do? We're gonna take 2 electrons from oxygen, and I'm gonna use the ones on the right-hand side, create a double bond. Now everybody's happy, okay? Carbon dioxide. Carbon has 4 valence electrons. Oxygen has 6, but there's 2 of them for a total of 12 valence electrons. So we have a total of 16 valence electrons, okay? Carbon always goes in the center, okay? So we're gonna have OCO. Go ahead and bond them. Those 2 bonds take up 4 valence electrons. We're left with 12. I'm gonna take those 12, and by putting 6 valence electrons around each oxygen to give it an octet, I've used up all my remaining valence electrons. If we do a happiness check, oxygen on the left is happy, carbon is not happy because it only has 4, and then oxygen on the right is happy. So carbon needs 4 more electrons. So what am I gonna do? I'm gonna take 2 from each oxygen and create a double bond, okay? So we're gonna do that, and this is now the correct electron dot formula for carbon dioxide. Moving on to N2, nitrogen has 5 valence electrons, but there's 2 of them for a total of 10 valence electrons. Go ahead and match them up, N, bond them together, you get 8 valence electrons left, okay? I'm gonna start with my left nitrogen, give it an octet for 6. I used 6 valence electrons. I have 2 left. I'm going to put the remaining ones on the left-hand nitrogen. Now, left-hand nitrogen is obviously not happy because it only has 4 electrons. The one on the right's happy. So the left-hand nitrogen needs 4 more. So what am I going to do? I'm going to take 4 electrons from the nitrogen on the right, and I'm going to take those 4 electrons and I'm going to give it 2 more bonds to create a triple bond. So this is the correct answer for N2. Write the electron dot formula for carbon disulfide. Okay, carbon has 4 valence electrons, sulfur has 6. There's 2 of them for 12, so we have 16 valence electrons. Carbon always goes in the center, so you're going to have S, C, S. Go ahead and bond them. Those 2 bonds each took 2 valence electrons. So now we're left with 12, okay? So we're going to put those 12 valence electrons around the 2 sulfurs, and I'm left with 0. If we do a happiness check, sulfur's happy on the left, carbon is not happy because it only has 4, sulfur's happy on the right. So carbon needs 4 more electrons to be happy. So what am I going to do? From each sulfur, I'm going to take 2 of each. So I'm going to take the 2 electrons from the sulfur on the left, create a double bond, and I'm going to do the same thing with the sulfur on the left. 2 electrons, and I'm going to create a double bond on the right. This is the correct answer for the dot formula for carbon disulfide. Moving on to OF2, oxygen has 6 valence electrons. Fluorine has 7, but there's 2 of them for 14. So there's a total of 20 valence electrons, okay? Put the lone atom in the center. That would be oxygen, okay? Now bond them. Those 2 bonds used up 4 valence electrons. We're left with 16. So I'm going to create octets with the electrons that I have. I gave each fluorine atom 6 electrons, so that was a total of 12. So we're left with 4. I'm going to put the remaining electrons and give it to the central atom, which is oxygen. Let's do a quick check. Fluorine on the left's happy, oxygen's happy, fluorine on the right is happy. This is the answer for oxygen difluoride. Sulfur trioxide. Sulfur has 6 valence electrons. Oxygen also has 6. There's 3 of them for a total of 18. 18 plus 6 is 24. Go ahead and put the lone atom in the center and structure it, okay? First, I'm going to delete all this to give me more room for the structure that we're going to make, okay? So here's how the structure is going to look. You're going to have the lone one is sulfur, so you're going to do O, S, O, O. Go ahead and bond them. So I have 3 bonds. So each one has 2 electrons. So I've used 6. So now I'm down to 18. Let's go ahead and give each oxygen an octet. And so by doing that, I've used up all my valence electrons. This oxygen on the left is happy, okay, because it has 8. The oxygen on the bottom is happy, okay, because it has 8. Oxygen on the right's happy because it has 8. Sulfur is not happy because it has 6, okay? So I'm going to take 2 electrons from the bottom oxygen, and I'm going to create a double bond with the sulfur. This is the correct answer. All right, moving on. Carbon tetrafluoride, okay? So we have carbon has 4 valence electrons. Fluorine has 7. We have 4 of them, so there's 28 with the fluorine for a total of 32 valence electrons, okay? So carbon always goes in the center, okay, guys? So let's do this. All right, so we're going to put carbon in the center, and then we're going to put our fluorines around it, okay, guys? So the structure is going to look like this. We're going to go ahead and bond them. So with those 4 bonds, we used up 8 electrons, so now we have 24. Now we're going to give each fluorine an octet, so we're going to give each one 6 valence electrons, okay? By doing that, every fluorine now has an octet, and I use 6 for each one to do that. 6 times 4 is 24. I've used up all my valence electrons. If you do a quick happiness check, everybody's happy. All the fluorines have 8, and chlorine has 8 valence electrons as a result of those 4 covalent bonds. This is the right answer, guys. Moving on to hydrogen chlorine. Hydrogen has 1 valence electron. Chlorine has 7. We have a total of 8 valence electrons. Go ahead and do your structure. Bond them together. So with that bond, we use 2 valence electrons, so we have 6 left. Remember, hydrogen is happy already, guys, because hydrogen has 2 valence electrons from that bond, so we don't need to worry about hydrogen. Chlorine, we're going to use the 6 remaining electrons to give it an octet. Hydrogen's happy. Chlorine now has an octet. This is the correct answer, guys. Moving on to chlorine. We have 2 of them. Chlorine has 7 valence electrons. There's 2 of them, so we have a total of 14 valence electrons. Go ahead and put them together side by side and bond them. A bond is worth 2 valence electrons, so now we have 12. So we're going to take the 12 remaining valence electrons and we're going to give each chlorine an octet. I gave each chlorine 6, so I used up all my valence electrons. If I do a happiness check, chlorine is happy, each one. So those are the answers, guys, to the assignment.